A satellite orbits the Earth in about 87 minutes. If its orbital radius is 6,500 kilometers, use this data to find the mass of the Earth. Well, we've been told this is a satellite here which is orbiting the Earth, and it takes 87 minutes to orbit the Earth. And so, for it to go around the Earth and come back to the same position, that is going to take 87 minutes. Now, what does that mean? So that means that is the period of this satellite. A period is simply the time taken to complete a revolution. We can actually even find the speed at which it is moving. Okay. We know that speed is given by distance over time. And so let me say velocity in this case, since we're in physics mostly. So distance here, the distance around the Earth, because that is going to make a circle. And the circumference of a circle, that is the distance around the circle, it is given by 2 pi r. And then divided by the time in this case, that is the period, the time it takes to complete a revolution. So this is going to give us velocity being equal to 2 pi. The radius between these the Earth and this satellite is 6,500. Now we need to convert this to meters. It's simply multiplying this value by 1,000 to get it to meters. So that becomes 6,000. Okay, that will be 6500, and then there will be 3 more zeros because we multiplied by 1,000 divided by the period. Now the period is, it takes 87 minutes, but this value is supposed to be in seconds. So let's convert that to seconds, and to convert to seconds is just to multiply by 60, because we know that in 1 minute there are 60 seconds. So this is going to give us a velocity of, so we have got 6500 multiplied by 2 pi and divided by 87 multiplied by 60. So that is going to give us 782 3.88975 meters per second. So this is the velocity at which this satellite is moving around the Earth. Now that we have got the velocity at which it is moving, there is always a force which is acting on the satellite and the Earth, pulling them towards each other. So this one which is moving has got a force that is pulling it towards the center of the Earth. So that is the centripetal force. So in this case, the centripetal force, there is also a force which is attracting these two objects, the Earth and the satellite. A force which is attracting them can be given by the Newton's universal gravitation force. So the centripetal force in this case is going to be equal to the universal gravitation force. And you know that centripetal force is given by mass times velocity squared divided by the radius. In this case, this mass is the mass of something that is moving. And then we have got the Earth which is stationary there with capital M. And this is going to be equal to Fg, that is universal gravitation force, is given by universal gravitation constant, and then mass 1, mass 2, and then divided by the square of the radius. So from here we can see the small mass cancels with the other small mass there. The radius is going to cancel. I'm just going to have one radius here remaining. So what we are going to have is v squared being equal to gm divided by r. So we can go on and substitute our value for v where there is v, the same value which I've just rubbed. So where there is v, we are going to put 7823.88975, but this is squared, and this should be equal to, where there is g, that is the universal gravitation constant, 6.67 times 10 to the power negative 11, and then divided by the radius of, okay, the orbital radius, that is the distance between the Earth and the satellite, that is 6500. We are converting that to meters, we multiplied by 1000, and then we have got m there. So this value which is here, when we square it, we are going to get 61213,250.83, and then we're going to multiply by this other value. We are going to multiply by 6500000, and then this one is on top, so we're going to divide by 6.67 times 10 to the power negative 11, and this is going to give us m alone. So we multiply by 6500000 and divide that by 6.67 times 10 to the power negative 11, and that is going to give us a value of m. Let me record it here. M is going to be 5.96503 times 10 to the power 24. So this is going to be the mass of the Earth. I can write it to three significant figures. That is going to be 5.97 times 10 to the power 24 kg. So that becomes the mass of the Earth then.